Hello all, welcome to Programmers World. Myself Harish. If you are first time watching the videos in our channel, then I will give a short intro of it. So this channel completely deals with learning programming languages simple and efficiently. So if you are here to learn various programming languages in simple and efficient way, do subscribe to our channel and watch the videos and enjoy it. So let's get into the video. So in this video, what we are going to take a look is the operators concept. So what are all the various kinds of operators present in Python and what is the each and every functionality of each and every operator. So we are going to take a deeper look on each and every operator, how it performs, what kind of result it returns and everything with some samples also. So basically why operators are used in every programming language. The basic purpose of using an operator is it is a symbol that performs certain operations. To perform any kind of operations in a programming language, we need a symbol and that symbol is known as an operator. So Python provides a set of operators. Those are arithmetic operators, relational operators, comparison operators, logical operators, bitwise operators, assignment operators, and then special operators. We would be seeing up to bitwise operators in this video. In the next video, we will be seeing about the assignment operators and special operators, and also we will be speaking about the operator precedence in the next video. So in this video, we will be covering the first four types of the operators: arithmetic, relational, logical, and bitwise operators. So we'll see one by one. So we will start with arithmetic operators. What is arithmetic operators is? It's basically used to perform some mathematical operations, and yes, plus and multiplication symbol can be used for string also. We will see in detail. So these are the list of arithmetic operators that are available: addition, subtraction, multiplication, division, modulo, floor division, and exponent or power operator. So explaining this, I will explain it with the sample, so that would be very much easy for you to understand it. So I would open the Python IDE ideally, and then so addition operator there is not much to do with. So simple, it's just do the simple addition only. So there is not much to deal on with it. So I'm not going to deal much into it. So even if I give floating point value, it will be adding it. So it performs a normal addition as we do in mathematics. So the same for subtraction also. It holds it can return the negative values also. So as we do subtraction, so the thing here is addition, subtraction, and multiplication. These three things it would be as same as we do for multiplication or as we do for normal mathematical operations. So it's going to be the same. So I'm not going to go in depth on it by providing more samples. I'll just show for multiplication also one thing. So we get the result. And then the division operator. The division operator is the operator which is used to return the quotient. In the normal mathematical division, we have dividend, divisor, quotient, and remainder, four parts. The dividend and divisor are the two arguments that we will be passing to divide it. So if I give 10 divided by 10 divided by 5, I'd be getting the answer as 2.0. Where could be our quotient? So since 2 is the quotient, we will be getting the value as 2.0. And here why we are getting as 2.0 is this division operator will always return floating point only as the result. Even if we divide a floating point value or even if we divide an integer value, it will always return a floating point value. If I divide 10.5 divided by 2, it will be resulting the respective result 5.25, but everything it will be resulting in floating point only. The result of a division operator will never be an integer. So this is about division operator. And then the modulo operator. The purpose of the modulo operator is to show the remainder of it. So if I give 10%, that is the modulo of 2, I will be getting the answer as 0. Why I am getting this answer is, when we divide 10 by 2, the answer, the remainder that we will be getting is 0. So that's the reason. If I give 10.5 percentage to, I'll be getting some sort of remainder like 0.5. So this is about the modulo operator. And the next operator is the floor division operator. So what does this floor division operator mean is, it returns the, so if I give 10 floor division operator divided by 2, it returns the 5 only value. So the difference between this floor division and normal division operator is, in normal division operator, we will be getting every time the result as a floating point value only. But in floor division operator, if the arguments are integer, then we will be getting the result as an integer only. And so this is one first difference. And the next difference is, if any one of the argument in floating point is of type integer, then if is of type float, then we would be getting the result as floating point value. So here, in the above example, 10 floating point operator divided by 2, I will get the answer as 5 as an integer value, and now 10.0 I am giving it. So the floating point value. So is, as one of the argument is of floating point value, I will be getting the result of the floor division operator as floating point value. And the last difference is, if I give 10.5 floating point operator by 2, I will be getting the same result as I got for the 10.0 by 2. So what's the last difference is, like between the floor division and division. In the division operator, we will be getting the exact quotient value that we get by dividing those two values. But in floor division, we get the rounded off value in floating point. So the decimal part, that is after the dot, is ignored and it just prints only dot 0. So we will not be getting the value after the decimal part in floor division. So when we want to do some round off operations kind of stuff, we can use this floor division operator. And then the last arithmetic operator is the exponent or power operator. So the exponent or power operator is nothing but the power of 10 power 2. So if I give like this, that is 10 square. So 10 square would be 100. So I'll be getting the result as 100. If I give 10 power 3, so 10 cube it will be. So 10 cube would be 1000. So this is about the exponent or power operator. So that's what I would have been explaining here. The slash operator always performs floating point arithmetic, hence it always returns the float value. But floor division can perform both floating point and integral arithmetic. If the arguments are int type, then the result is integer type. If at least one of the argument is of float type, then the result is float type. Okay. And then the next thing that we will be seeing is addition and multiplication operator can be used for string data type. How means, there are some conditions. When we are using the addition concatenation operator, string concatenation operator, at that time both the arguments should be string only, else you will be getting a type error. Whereas in the case of multiplication operator, one argument should be compulsorily of type integer only, and it should not be of type float also. It should be of integer, and the other argument should be of string. I'll just show a sample of it. So if I give Harish plus, I didn't give a string. So Harish, I am giving a string, plus I am giving another string of Balaji. So I get the output, string concatenation is done, and I get the desired output. Suppose if I give Harish plus, if I give an integer value, it will throw an error, can only concatenate string, not int to string. Okay, this is about concatenation. And then speaking about the multiplication, I said one of the values should be of integer. So Harish into 2, I'd be getting the value Harish, Harish. So it will be printing the number of times that we give in the integer value. If I give 2.5, it would be throwing can't multiply the sequence by non-end of type float. So we can give only integer value here. So this is about how the addition and multiplication operator gets overloaded with the string operation. And then the last point is, as we all have in the same as other programming languages, when we divide any number by 0 or when we use the division or the modulo operator, it will always raise a 0 division error. So divide by 0 error, we will be, as we get for all other programming languages, in Python also we will be getting this 0 division error when we do this kind of operation. So this is all about arithmetic operators. And then the next operators are relational operators. So the relational or comparison operators, these are a set of operators that is used to compare two values. So the list of relational operators are greater than or equal to, lesser than and lesser than or equal to. As the name itself denotes, it returns the condition based on the operator that we are using, greater than equal to, less than or less than equal to. So I'll just show some quick samples here for relational. So 10 greater than 20, it would result as false. 10 is not greater than 20. 10 greater than or equal to 20, the same as false. 10 less than 20, it's true. 10 less than or equal to 10 or 20, it's true. So it's just simple. The normal mathematical operation only, this also the comparison operation only will be doing. One thing to note in the Python for the relational operators is chaining of relational operators is also possible. And yes, another point is relational operators can be applied for string type too. How it would be applying for string type is, okay, first I am having a string Harish less than, I'll give the same string here Harish. If I see the output is false. If I give less than or equal to, less than or equal to, the output would be true. So it doesn't compare with the, what to say, the length of the string. How it compares is with the ASCII code characters. If I give Harish less than or equal to, I will be giving only, suppose A, B, C. I'd be giving capital letter values. So 3 values. Let me give another also, A, B, C, D. So here the length of the string is 4, but here the length of the string is 6. It will not compare the length of the string, it would be comparing each and every ASCII code value. Suppose if the value of H, the ASCII code value is somewhat 92 means it would be adding, and if A is 97 means 92 plus 97. So like that it will be summing up the value of the string, and then this string, it will also be summing up, and it would be comparing it, which value is greater. Based on that, the operator that we are using, it would be resulting the respective result. So it's still false. If I give, I think A or X, Y, Z, I will be giving X, Y, Z. It's still false. Okay, let me give another thing, W, false. I think okay. So I think the reason why we are getting false is the ASCII code values of capital letters are lesser than the ASCII code values of small alphabet, lowercase letters. If I give more digits, then probably I would be getting, I think. So if I give Z, now it's false. Okay. So this is about the operators that we use here. Relational operators. And then yeah, chaining of relational operators is possible. So in chaining, if all comparisons return true, then only result is true. If at least one comparison result false, then the result is false. I would explain how this chaining works. So what I would do is 10 less than 20, less than 30, less than 40. This would result us in true. But if I give 30 greater than 40, this would result us in false, because this condition gets 10 less than 20, this condition gets satisfied, 20 less than 30, this also gets satisfied, but 30 less than 40 fails. So if any one of the condition gets failed, then the total chaining operator result would be of false only. If everything gets succeeded, then only we would be getting the result as true. So this is about the chaining operators. And then the next set of operators would be the equality operators. So there are two equality operators, double equal to and not equal to. So this can be applied for any type, and here in this equality also string is chaining of operators is allowed. If at least one comparison results false, then the result is false, otherwise the result is true. So I just show a sample of it. So 10 equal to 10, it's true. We can apply for any type. So Harish equal to, if I give small letter Harish, it's false. Whereas if I give capital letter Harish, it's true. And then we can compare the boolean also, true equal to true, it returns true. Whereas true equal to false, it returns. And the same holds for not equal to operators also. True, not equal to false, I'd be getting the result as true. Harish, not equal to lowercase Harish, I'll be getting the result as true. So this is about the equality operators, and here also, as I said, chaining can be done. 10 equal to 10 equal to 10 equal to 10 not equal to 20. This would result us in true. If I this also give equal to, then this would result us in false. So the same as we did for the relational operators, the chaining condition falls here also the same for equality operators. And then the next set of operators is the logical operators. So there are three logical operators, and, or, and not. This can be applied to any types. So when speaking with the boolean type values, and when we are trying to apply these logical operators for boolean values, how the result would be like, if we apply the AND operator, if both the arguments are true, then would be resulting as true. If at least one of the argument is true, then the result would be true in the case of OR operator. The not would be the complement. If we give true, it would return as false when we use not. If we give false, it would return as true. So I'll just show it. So true and true. It would return as true, true and false. It would return as false, true or false. It would return as true, not of true. It would return as false. So this is about the logical AND or not for Boolean values. Now we'll be seeing for non-Boolean values. There is some logic here. The non-Boolean values, how it would be taking up is, and 0 means it would be taking it as false when you give some digit. Non-zero value, it would be taken as true. Okay, and an empty string would be treated as a false condition only. So if we have x and y, and if x evaluates to false, then x is only written, else y. If the first argument is 0, then the result is 0, otherwise the result is y. Okay, So I will explain what is about this. X and Y. Suppose if I am giving 10 and 20, what I will be getting? The output is 20. The first one is a non-zero value. So and the next one is also non-zero value. So if the first one is a non-zero value, I'd be getting the value that has been given after end. So if I give 0 and 20, this would be returning 0. So it is false. So this kind of thing, when we blankly execute this statement, this is how it will be executing. This logical operator can be used in if and else conditions, those kind of things it can be used. I'd be explaining it in detail when checking with looping statements. So the thing is, the first argument should be true. If the first argument is true, then only the second argument would be checked. If the first argument itself is false, then it will simply return the result as false. So if you want, I will just show with the if sample. Don't worry with the syntax. We will be seeing the syntax in detail. Okay. If 10. So here, if I give, okay, if 10 and 20, print if block. Okay. Else print else block. So now if I guess what the output would be, you can see the output is if block. So as I said, in the AND operations, the non-zero value would be treated as true. So if I give 0 and 20 now and try to print the if block, else print the else block. So here I'll be getting the output as else block. So this kind of thing we can use, and we can combine here also. Like how I can do is if 10 is less than 20 and 20 is greater than 10. So I will be printing the if block, else print the else block. So if block gets printed. So combination of relational and logical operators can also be done. So this is how I will be explaining the syntax of if and all in detail in the flow control statements. So just how the operators will be functioning. So if the first statement gets true, then only the second condition would be checked in logical and. In the case of OR, it would not be the case. If the first condition itself is true, then it would just print it. So I'll just show the same for OR operator. So I'll be using this if 10 then 20, and here I will be giving a false statement 20 less than 10. This is false, but I am using OR operator, and then so I'll just print the if block, else print else block. So now I am getting the output as if block. So the thing happens between the AND or OR is if the first argument is true, then the second argument will never be checked in case of OR operator. If the first argument is false, then only the second operator would be checked. And if the second arguments are also false, at that case only the else block will be executing. So this is about AND OR, and not as simple. We would be just getting the complement of it. Okay. So not of 10 is false. Not of 10 is false. Why? Because any non-zero value would be treated as true. a 0 value and an empty string value would be treated as false. So that is what. So this is about the logical operators. And then the next set of operators is the bitwise operators. So the bitwise operators are the operators that are used to perform operations with bits. So in the form of zeros and ones, the operations will be performed and the respective result would be returned. So these operators can only be performed with for integer and boolean types value only. Apart from this, it cannot be used for any other uh, type of value like floating or string. It cannot be used. If we use it, we would be getting an error as type error. So these are all the list of bitwise operators. It is and or not, complement, shift, left shift operator and right shift operator. We will see one by one what is its use. This one I will explain it later regarding the most significant bit. This is general notation only. The bits when we are representing in 8 or 32 bit, the most significant bit, that is the rightmost bit, would be treated as the most significant bit. If it is 0, it is a positive value. If it is a 1, it is a negative value. So that we are speaking about here. So we'll see about the first operator, how the bitwise AND works. So if I give a equal to 10 and b equal to, so if I give suppose 10 and 4. So when I use bitwise AND operator for 10 and 4, what result I will be getting is 0. We'll see why we are getting the result as 0. So I have provided an explanation with here. So the binary representation of 10 would be 1010. So it is of the form that binary representation, and 4's binary representation would be 100, that is 0100. So when we do this AND operation, what happens is here what I have defined is if both the bits are 1, then only the result is 1. Otherwise the result is 0. So if you take a look at here, 0 and 0. So the result is 0. 1 and 0, the result is 0. Both the bits should be 1, then only the result would be 1. So here in no case, here we are having 1, but here we are having 0. So since all the values are 0, the decimal equivalent for this binary representation number is 0. So that's why we are getting the result as 0. Suppose if I give another representation 4 and 5. So here I will be getting the answer as 4. How means how I will be getting the answer as 4 is because I'll just show with another example here. So the binary representation of 4 would be 0100, and the binary representation of 5 would be 0101. So here what would be the result? So here if you take a look at result, I'll just enter the result 0100. So why? Because 0 and 1. So both the digits are not 1. So it's 0. Here both the digits are 0. So it's 0. And here both the digits are 1. So here the result is 1 here. And it's 0. So binary representation is 0100, which is equivalent to the decimal value is 4. That's why we are getting the result as 4 and 5 would be resulting as 4. So this is about the bitwise AND operator. The same holds for the OR operator. How the OR operator would be performing is, if at least one bit is 1, then the result is 1. Otherwise the result is 0. So let's take this case itself. 4 or 5. Sorry, 4 or I gave 4. 4 or 5. Now I will be getting the result as 5. Why? Because if you take a look at this, when you do the OR implementation, any one digit only needs to be 1. So here I will be getting 101. So 0 and 1. Here the one digit is 1. So we are getting the 1. And here 0, 1. If both the digits are 1, then it's 1 only. If both the digits are 0, then it's 0. So 101 is equivalent to this representation, decimal representation of 5. So we are getting the result as 5. So that's what bitwise OR is working on with. So 10 and 4 will be getting the result equivalent as here 1, here also 1 is there, and here also 1. Only the last digits of both the things are 0. So that's why we are getting as 1110, and its decimal equivalent is 14. So this is about the OR operator, and this NOT operator is simple. The bits are different, then only the result is 1, otherwise the result is 0. So 4 and 5, both the bits, if I give 4 and 5, that is 4 not 5, I would get the result as 1. Why I am getting the result as 1 is both the bits are different. But if I give 4 and 4, that is 4 not 4, both the binary representation of 4 and 4 would be same only. So it would be 100, and here also it would be 100 for 4 I am making. So since it's for both the same, both are same, we will be getting the result as 0, because if both are different only we will be getting the answer as 1. So this is about the NOT operator for bitwise. And then the next operator is the complement operator. That is 1 means 0, 0 means 1. I have provided a pictorial representation. Here we will be using the 2's complement formula and all. We need not take a deep look into it because when we are working on with the programming, these kind of 2's complement and 1's complement and all are not that much necessary for us. We just need to know what happens. So I have provided it here. So suppose if I give 4, and if I give bitwise complement operator of 4, what I will be getting is I would be getting a negative value with the value that I have been included. So if I give bitwise complement operator of 5, I would be getting as minus 6. If I give the bitwise complement operator of 6, I would be getting minus. So addition to that one value and the negative sign would be represented. How this is coming is that one I have shown here. So the representation of 4 is 001. This is the 8-bit representation, and then when I convert this, as I am using the complement, zeros should be converted to 1. So as you can see here 1, and this is 1, and 1 would be converted to 0, and the rest are 0, so the rest here are also 1. So when we take this form of representation, and since why we are getting the minus sign is, I said here the most significant bit acts as sign bit. 0 value represents positive number, whereas 1 value represents the negative value. So since we are getting the value as 1, we will be getting the output as negative value. If I give a complement of negative value, so in that case the most significant value for us would be 0. So the same we will be the minus 4 will be getting its equivalent. So once we get this value, when we do the 2's complement, that is when we add 1 with it. So when we do the 2's complement, that equivalent representation is equal to this minus 5. So if you want to know like a short logic, if we do a complement operator, the value that we are specifying, the number that we are specifying, if it is a plus number, add a number to it, and since it is a positive number, put a minus sign. So 4 plus 1 would be 5 and a minus sign. So that is minus 5. If we are giving a negative integer, minus 4, so in that case, minus 4, what we need to do is subtract the number as we are given a negative number, minus 4. So 4 minus 1 would be 3. And since we are giving a negative value, we need to put a positive symbol. So internally this happens. If you want to take a deep look into the 2's complement also, please mention in the comment. I will be providing a separate session for that. But 2's complement is not required here, as it would be mostly used in the digital electronics, those kind of stuffs only. So this is about the bitwise complement operator. And then the next operator, that is the last operator, is the shift operators. So we are having the shift operators. One is the left shift operator and the other one is the right shift operator. So I will explain the functionality here. So the left shift operator, how it performs is, it will be shifting the bits towards the left, and the left out spaces, that is the empty bits area, would be filled up with 0 in the case of left shift operator. So as I can see, the binary representation of 14 is being here. So it's depicted here, 4 zeros, 3 ones and 0. When we do left shift of 1, we are moving one digit to the left hand side. So as you can see, the 1 which was in the second place has moved on to the third index. And this empty box would be filled up with 0. So once we filled up with 0, we will be converting that one into its decimal equivalent, and we will be returning the result. For better understanding here, I would have been giving the left shift operator example 00010. So this is representation of 2. So when I try to do the left shift operation of 2, so 2 left shift operator, and I am moving the bits, 2 bits I am moving on it. So when I move 2 bits, what happens is, so this one would be converting 2 bits here. So excluding this, and it would be coming here. Remaining would be 0, and this 0 would be coming here. And since we are left out with 2 digits, so this one we will be filling it up with 0. So when we take the decimal representation of this, it is 1000,000. So should be getting an output of 8. So if I check it, we will be getting the same output as 8. So this is the left shift operator. Speaking about the right shift operator, it does the same functionality as left shift, but the thing is the bits are moved towards the right, and the empty boxes will be marked as 0 or 1 based on the condition. If you are giving a positive value, then 0 would be assigned. If you are giving a negative value, then then 1 would be assigned. So here I have given the representation of 4. So if I give 4 right shift operator of 2, so here this is the representation of 400, and since right shift operator, so we are moving 2 digits, and 1 would be coming to the last one, and the remaining is these 2 boxes would have been empty, and it's filled up with 0. So its equivalent representation is 1. The decimal representation of this 8-bit representation is 1. I hope the answer we will be getting is also 1, and we get the same result. So this is about the shift operators that we are using in Bitwise left shift and Bitwise right shift operators. So this is about the Bitwise operators. So we are left out with the assignment and special operators and ternary operators. So these operators we will be seeing up in the next video. I hope you would have liked this video. Guys, comment if you have any suggestions, and then do subscribe to our channel and do watch our videos regularly. Thank you.